Let's consider example 2. Factorize xy minus xy square. What is our HCF? The HCF of xy and minus xy square is what goes in xy and also in negative xy square. You can see that xy goes here one time. Xy goes here and you have what left? Negative y left. So 1 and negative y, nothing goes in them again. So that means it is xy that is our HCF. Note it down, xy. Now bring that HCF outside a bracket, and inside the bracket put the expression xy negative xy square, bracket closed. Use the HCF you bring outside to divide each of the term in the bracket, divided by xy divided by xy. So this gives you xy divided by 1. Xy divided by xy is 1. Minus x cancels x. Y in y square is y. That's the answer. Don't forget, y squared divided by y means y times y divided by y. Y cancels y, you have y. I hope it is clear. So that is how to factorize that. Let's go to example 3. Let's consider this example 3. It's a bit different in format, but it's just a twist of what you have already known. If xy square is a factor of 2xy square minus s square y square, find the other factor. In short, you are just to factorize the expression given to you. And by the time you factorize the expression given to you, definitely the two factors you will have, one of them would have been xy square. And the other one is what you are asked to find. Can you see it is as simple as anything? So let's factorize 2xy square minus x square y square. The HCF of this, now HCF of the two terms is, if you look at it, x y square is common to the two terms. And that's the highest factor that is common to them. So you have x y square as your HCF. Bringing it outside, x y square into 2xy square minus s square y square. Using the HCF to divide each term in the bracket, you write xy square divided by xy square. And that gives xy square into, look at it very well, x will cancel x, s square will cancel, y square will cancel y square. You have 2 left. Minus x in x square gives you x. Y square cancels y square. That is the answer. You can see that the expression has been factorized into two factors. Two factors, xy square and 2 minus x. And xy square has been given right from the beginning that if xy square is a factor of this, which is true, it's a factor, find the other x. So what is the find the other factor? What is the other factor? 2 minus x. Now right, therefore, the other factor is 2 minus x. Simple We now come to another subtitle under quadratic expression. We call it factorization of difference of two scale. Factorization of difference of two scale. See, in this, there is a principle of difference of two scale. Anytime you have two scales, that is, two numbers that are perfect scales, they are what we call two scales, because Every perfect square could be raised in power 2. Could be raised in power 2. And anytime you have 2 of them and you want to subtract 1 from the other, then we are talking about difference of 2 squares. Difference is subtraction. Subtraction is difference. So difference of 2 squares. Example is a square minus b square. Anytime you have it like this, a square minus b square will be equal to a minus b in brackets into a plus b in bracket. You will be saying, okay, why only a minus b first? It could be the other way around. It could be a plus b into a minus b. I hope it is clear. Now, this difference of 2 squares we are talking about always involves 2 perfect squares. Always involves 2 perfect squares. And every perfect square could be raised in power 2. E.g., 1 is a perfect square. And it could be raised as 1 square, which will still be equal to 1. It will still maintain itself. It will not be disrupted. If you take 4 as a perfect square, 4 as a perfect square could be raised as 2 square. And don't forget, 2 square is always 4. Another perfect square is 9. 9 could be raised as 3 square. And don't forget, 3 square is 9. You can see we start from 9, we end at 9. We start from 4, we end at 4. Start from 1, end at 1. Finally, for now, we have them uncountable. We have numbers of perfect squares. But for now, because of our time, another one is 16, which will be raised as 4 square, which eventually gives us 16. By default, you yourself can generate numbers of perfect square by just writing 1 to infinity. If you write 1 to 11 and you begin to scale 1, it will give you 1. Scale 2, it gives you 4. Scale 3, it gives you 9. Scale 4, it gives you 16. Scale 5, it gives you 25. The answer you get, they are perfect squares. So that is that. So let's move to example 1. Following the explanation I have given you, let's consider example 1. Factorize the following. A square minus 1, which is the question A. The first thing you do, once you realize that there is a numeric aspect of it, the minus 1 is the numeric aspect. And that numeric aspect is a perfect square. As you can see, that 1 is a perfect square. So express it the way it should be. See, this should be a square minus 1 square. No, minus 1 square is the same thing as this. You now remember the format that you go with this. Remember a square minus b square, which is equal to a minus b into a plus b. So this also will be x minus 1 into x plus 1. It's as simple as that. That's all. Question B, which is 3x squared minus 27. Looking at this, you see element of simple factorization there. You see that something is common to the 2 terms, and that is the HCF. So you say HCF is 3. 3 is common to them. Look at it very well. 3 is the HCF. So this is the interference of the previous one in the next one we are doing. Under the factorization of binomial, simple binomial quadratic, we can see that we use this. Now, under the difference of 2 squares, we are still going to use it because of interference of that. So, bringing it out, you will have 3 into 3x squared over 3 minus 27 over 3. And this is 3 into 3x squared divided by 3. That gives us x squared minus 27 divided by 3. That gives us 9. 3 into x squared minus 9 can now be interpreted x squared minus 3 squared. Can you remember? And finally, you say 3 into x minus 3 into x plus 3. And that's the end of that. We have factorized it. Yeah, let's consider example 2. Factorize the following. A, x squared y minus y cubed. Looking at this, you see that something is common to the two terms. And what is that? It is y. HCF is y. Y goes here, y goes here. So bringing it out, y into x squared y divided by the same y minus y cubed divided by y. So this gives y into x squared minus y squared. You know, y raised to power 3 divided by y means y times y divided by y. Y cancels y. You have y times y, which is y squared. So remember that this format has been given from the beginning in the format of a squared minus b squared, which should be equal to a minus b into a plus b. So y into x minus y into x plus y. That is the end of that. Question B of example 2. Factorize 2x cubed y minus 8xy cubed. The HCF here is 2. 2 goes in the 2. Also x, then y. The HCF is 2xy. So we have 2xy into 2x cubed y divided by 2xy minus 8xy cubed divided by 2xy. So 2xy, 2x divided by 2x cubed divided by 2x. 2 we cancel x. X in x cubed we have x squared. Y we cancel y. Minus 2 in 4. 2 in 8 we have 4. X cancels x. Y in y cubed we have y squared. So the figure, which is 4, is a perfect square. So you address it as xy into x squared minus 2 squared y squared, because it is a perfect square. So you express it in power 2. From this, if a squared minus b squared is equal to a plus b into a minus b, it doesn't matter if you have a squared, b squared, m squared minus k squared. It will be the same thing. It will be abm minus k into abm plus k. So infer that here. Our answer will be 2xy into x minus 2y into x plus 2y. And that ends factorization of difference of two squares. I want to believe you understand it perfectly. Thank you. Yeah, so far so good. We've been able to trace so many things under quadratic expression. We want to call it a day now. I have this assignment for you. Make sure you lay your hand on them, try them, and see how easy they will be for you. I'll give you the solution in the next class. Thank you.